Hello and welcome.
Hello.
How's everyone doing on this Palm Sunday?
Doing very well.
Excellent, excellent. So since we talked about kernels yesterday and Palm Tree, turns out that today ended up being Palm Sunday, so that we can remember.
That was a good one.
about the hardware being the kernel or inside the kernel, and then you have your kernel, your shell, the Palm, and then the Palm Sunday. Excellent. So how's everyone doing though? Did anybody sleep and dream about any anacondas last night?
We grew up with snakes in the around the house, so it's not something that I'll sleep and dream or be afraid of anymore.
Excellent, yeah. Excellent. So we should be ready to fight this python that wants to give us headache.
Yeah, I'm a CDC child, born and bred there, so
excellent, excellent. All right, so today we're going to jump in. Let me go ahead and maximize this. Actually, I wanted to be able to present side by side with Visual Studio Code, but we'll be writing some code today, quite a lot of code. So feel free to follow along. What I'll try to do though is I'll try to do the review. So do the talking, try to spend maybe as much as 10% of the time doing the talking, and then the rest we're going to be writing. Because like I said, we're learning this new programming language, which is like any other language. So our first few days, our first few times, we're going to be talking a lot of gibberish. That means we'll be making mistakes. It's totally fine. Most of the time, you'll be using in debugging your code, trying to find a bug in it, trying to find a mistake in it. So sometimes it might be frustrating for most people, and sometimes it might be easy if you take the smart route. So the code that you'll be spending time on might be code that someone else wrote that you're fixing, or it might be code that you write and you want to write in a way that others will be able to utilize it easily and well. So that said, let's go into, again, classwork for today. I did share with you already what we did yesterday. We're able to get a synopsis. The PDF is on there. And I believe I shared the videos. Yes, the videos are in a separate folder. So you can see there's a video for yesterday. Today's video is going to be uploaded once we are done. And also I have a resources section. This will have mostly vocabulary stuff. Okay, so it's always good for you to have some type of glossary. Words that did not make sense to you, you might want to come back and double check them. You might even have more words than I do. So keep track of that. You can always come back in here if you have a problem figuring out which word it is that we're looking at. Okay, that said, I hope everyone was able to log in still inside the Jupyter notebook on Anaconda in the cloud. You should just type in anaconda.cloud. It should take you on there, and we'll be spending the most time in there so that everybody is more or less working on the same computer, which is the cloud computer in wherever they're hosting it with the Anaconda guys. And again, our PDF is located on our website. I've already navigated on there. And instead of clicking yesterday's stuff, all I have to do is click on today's lecture. On today's lecture, I should be able to see the PDFs and we are good to go. All right, so before we get started, what questions do we have? Yes, go ahead, Mr. Nigel.
Yes, yesterday I was able to go to the just like right now I'm able to be on the cloud Anaconda, and I'm seeing basically the same things you're showing me.
Yes.
However, when you say PDF, is that based off a link you had shared, or like how do we? Because in order for me to get a PDF, it is. I mean, is there a specific PDF to this class? I'm gonna assume. If so, how do I get to it? That's my question.
Very good question. So to get to the PDF, okay, first off, you have to go to the website. If you go to dkv2s.org/learn, learn starts with a capital L. Otherwise, it will take you to my old website. From here, you can navigate to programs and select Python, or you can click on programs and search through it. And that should take you to our Python page. On our Python page, you should be able to see a description that outlines our objectives. And the second tab has a curriculum. In that tab, you should have a link. When you click on that, it shows you on the side the PowerPoint that I'll be presenting today. This was for yesterday. If I click on today's lecture, I'll have that for today. Hopefully, I'm going to keep color coding it so you can tell the differences easily if you can. That way, you don't have to concentrate to read day 2 on here. But to get the PDF, if you go to our classroom and you check on the classwork, currently I have not yet posted day 2. I'll post it after we're done. And I've not yet posted the assignment as well. That's why it's grayed out on my screen. So
Okay.
click on day 1, you should be able to see a PDF.
Yeah, Prof, sorry, I'm having issues because when I go to the DKV, okay, I made the mistake of going to dkv2s.com.
Yeah.
But when I go to .org, it's giving me 404 page not found.
Okay, very good. So that's probably because you spelled it with a lowercase l for learn.
Oh, yes. Okay.
Yeah. And I'll go ahead and also add that in our resources on here so that if you are having access to the website, to the classroom, you should be able to get that on there. Let me go ahead and just create a new material.
I've posted the link in the chat.
Chat as well. Excellent.
All right, thank you.
Excellent stuff. Very good question. I'm glad you were able to speak up. Anybody else has any concerns, questions they would like me to address? Awesome. So let's dive in to the curriculum for today. Before I dive into the curriculum for today, are there any things that you remember from yesterday? Nigel, let's start with you. Is there anything that you remembered from everything we talked about yesterday?
Yes, yes. I remember that Python is an object-oriented program, like you said. And when we talk about object, you were talking about being something. I think it's something targeted at something physical. You know, like an object, something. You know. We talked about the shell and the kernel.
Yeah.
And I'm glad we actually talked about that, because years ago, when I did Linux, we used to talk about when we were talking about the servers, we talk about the shell and the kernel, but I did not quite understand like how they differentiate. I'm sure that, I mean, what I'm trying to say, I did not know the difference. I didn't really know the difference between a shell and a kernel until you broke it down in in layman's term. So, but basically, there's, I mean, I can go on all day, right? But there's just a little bit of fun like that yesterday. And the one thing I was going to tell you was my hope was that, I mean, I think I'm going to be wrong. Because like I said years ago, when I was trying to take a programming class, they used to say that programming they say you learn to run before you walk, or is it you learn to walk before you start creeping, you know? So the scary thing about it used to be is that they just start coding and coding and coding, and you don't understand what they're doing. They say you learn the, you know. So usually in my mind, you have to learn something first to apply it. My hope is that you will be different from that.
Good. Yeah. Today you're going to have baptism of fire.
Oh my goodness. All right.
Good synopsis. Thank you for sharing. Aaron, anything you'd like to add in there?
Oh, for sure. So I have zero technical background, as I mentioned to you the other time.
Yeah.
I'm not a tech guy. My background is in management. So, and I just, thought, I should start having fun by looking at some other stuff. I'm not sure if I'm going to transition or not, but I just thought, why not just look at some other stuff, right? So yesterday I was, I really liked the way, there was a PowerPoint slide that started with data type, and then we moved into variable, and then from there statement, a function, module, package, and all that stuff. To me, that was very good because it answered a lot of things that I've been trying to understand, right? And it really helped me in, maybe just have a structure of, hey, when should I understand what a variable is? How should I understand what a function is? So yesterday in the night, around midnight, I had to look at that same slide multiple times because it was answering a lot of equations that I have.
Good.
So for me, that was, really, really good. And I hope we're gonna continue by using examples that are closer to home. I mentioned I'm a CDC child, right? So if you're using this language, it speaks to me, right?
There you go. Yes.
Yeah, I'm looking forward to this today and subsequent sessions.
Excellent, bro. I'm very glad to hear that. And that slide, it's funny because I almost took that slide out. I thought it was too goofy, but good thing I left it in there. Again, you see most people in IT, even most people writing code and programming, they do not understand those concepts. One thing that always gets confusing is the difference between library and framework. People don't know what's the difference between it, but if you look at it, say in a sense that with a framework, you already have a foundation, you have the pillars, you have everything. All you have to do is write your code to add inside your framework and continue with your program. But a library, you are trying to dig your foundation and set everything, and then you borrow code from other people and add it in there. So your house is almost done. You have to go and buy zinc somewhere, or you're running out of cement. You go and buy some blocks to come and add it and finish building your house. So that's more like a library, borrowing stuff that you don't own and using it and so on. But yeah, good thing for sharing, or good thing you shared that. How about you, Mr. Fabian?
God, where do I start from? I mean, I'm not gonna be repeating what other people have said.
Yeah.
But outside of that mindset, I'm also in love with how you are using technology to dispense information, right? I enjoyed your use of Google Classroom. It's one tool in the Google toolkit that I've not really explored, but looking at how easy it is to send alerts, but moreover, you will never hear somebody complaining, oh, my computer crashed and I can't access this, which is the beauty of using cloud, right? I mean, it shows how we are embracing technology as a whole. But thank you again for, just breaking down, chewing those distros for us. I was listening to the video when you sent out, and my wife was passing around. It's like, which one is Jython now? This IT thing will never end. Just started laughing. I'm like, if you don't get the context, it can be scary. But just by her listening to Jython, it's like, so there is Python and there is Jython now. Say, yeah, okay.
Yeah, you should tell her and ask her that. So there's also Ghanaian fried rice, Senegalese fried rice, and Cameroonian fried rice. Yeah.
But yeah, thank you so much for breaking down that down for us. I'm going to be the last person standing in this class, like not over promising like Peter and Jesus would in their conversation. But this is so important to me, so meaningful. I'm just so happy that I've come to someone that can really, like, who was mentioning about the CDC chair, Mr. Aaron, like someone that can bring this closer to home.
Yeah.
And I'm seeing like someone like me in the picture. If this guy can do it and talk like this, then why can I not do it, right? Yeah, those are some of the things that are really outstanding with you. And your use of language in general, your choice of words to contextualize things is really good. You know, we come from a background where somebody wants to say something, he will drag it, go around, finally land somewhere, and even you, the listener, you're getting confused. But you're specific to what you are saying, and you just make it in a language that is palatable, we can easily consume. Thank you for that.
Awesome, awesome. So you guys keep giving me feedback on the teaching. That's great. But I wanted to grasp what you have studied. So now I'm not going to ask for feedback on this again until after the class. But that's very good what you've shared so far. And some of it has to come from failure, right? Because I've failed in the past and I've grown, I've been able to learn these things. And there's no need for anybody to fail the same ways that I've failed. If you want to fail, figure out a new way of failing. You know, if I've already done that, made a mistake, then I need to steer you away from that so that we can all move, you know, in a better direction. In that same light, let's carry on with today's stuff. Hopefully we can get this out of the way quickly. So today we're going to talk about data types, variables, statements, and expressions. In a nutshell, the few things we need to achieve or accomplish. Defining what a variable, defining what a value, a data type are, and also working with variables. We'll look at statements and comments, and probably take a break at that point. That way your head is not fried, and then come back and look at how we can get user input and also speed out some output. So in a big picture, we'll learn all those topics: values, variables, data types, statements, and discuss expressions as well as input outputs to the console. What questions do we have so far before I jump in? Going once, going twice, going 3, 4, 5, gone. All right. So.
Oh, no, sorry.
Go for it.
I was going to take myself off mute.
There you go.
So do you want everybody to be on the cloud?
Excellent. Very good question. I would love everyone to be on the cloud, but it's okay to also be on Visual Studio Code. That's totally fine, because at the end of the class, at some point, once we have gotten very comfortable with writing the code, I'm going to show you guys all the different tools that you can use, the different IDEs, and you can choose. You can pick and choose. It's up to you. If you want to use a hammer or a saw or a spanner and so on, it's the same code that you write. We can write code from one and export it to the other. So what I intended to do actually, when we're looking at the second part of the program after break today, I'm going to have these side by side so that you can look at both the code and also the Visual Studio Code. So we'll be working in the cloud as well as Visual Studio Code on both of them. Sounds good?
Yeah, cool. Thanks.
You're very welcome. Awesome. Very good question. All right. What other questions do you have? Okay, no other questions. So let's jump back in.
Quick question.
Yes.
Somebody said they will post a link to, because I'm on your website, I'm just dancing through. Somebody said we were going to post a link to the PDF. If it can be posted, okay. I really appreciate it.
So let's get you to share your screen, if you don't mind, so I can walk you through it. That would be a good opportunity for everybody to also jump in. I'll go ahead and stop sharing my screen so you can share yours.
No,
By
I
the way,
put it in the
I'm here
Google
with two
chat
screens.
here with the complete path to it, so that if you click on it, it just takes you there.
All right. So let me see. Present now. Please 1 second.
So yeah, everybody should start feeling comfortable to present, because it will be good for us to write our code and show it off. Or if you write your code, you have an error, we can decipher or debug the error together. It's always going to be good for our experience. Okay. Any luck? You're on mute in case you're talking. Okay, I cannot hear you, Nigel, so you might be still struggling
Okay,
to
yeah.
get.
Yes,
Okay.
yes, sorry. Yeah, what I was saying is that I think I still have to go to my settings to allow to share my
To allow your screen to be
screen.
shared.
Yes, which is
Okay, so let me show you again on
Mhm.
my screen then. So are you able to get to this page, the Python page?
Yes.
Okay, so when you get to the Python page, if you scroll down, you'd
mhm.
see there's a description with objectives, with our learning objectives. Right next to that description, and next to it, you see a curriculum tab. So you can click on the curriculum tab.
Hold on, maybe do I have to sign in, register first to be able to see that?
No, you don't need to register for this one.
All right, because for me, under the Python page right now, right?
Yes.
What it says is here the option, it says join class online with Google Meet. Then there's a 5 days, 23 hours and
Yep,
6 seconds.
countdown. So keep scrolling down a little bit.
Then now we have week 1, week 2.
Okay, so right before week 2, there is a link that says day 2, right? Lecture 1.2.
Yeah, okay. So so the issue I'm having is that mine is not the hyper, is that under learning objectives? Because mine is not the hyperlink. That's what But just hold on.
Okay, so you're looking at description. Right next to the description should be curriculum.
Okay, so I should click on should I click on description?
Click on curriculum.
Okay, click on curriculum.
Yes.
Okay, all right, I see.
Awesome. Then now you should be able to click on day 2.
Okay.
And you can expand it to full screen if you want, and navigate. You can navigate yourself back and forth as you need.
Okay.
But at the end of class, I usually send a PDF at the end of class in case there are any things that need to be edited, because I find myself having typos sometimes.
Okay. All right. Sounds good. I got it now. Thank you.
You are welcome. Good. So let's proceed. We've talked about the objectives and the overview. So to get started, values. Let's talk about values and data types. What are values? Values are just one of the basic things that a program works with, right? You can talk about 25. 25 will be a value. Those who work in data fields, let's say data analytics, data science, databases, and so on, you understand a value could have many different types, right? So think about an Excel file maybe. When you enter records in an Excel file, you can enter a number or you can enter a character. Think about your trip also to the DMV. When they ask you to enter your information, you have to enter information of a particular type. If they ask for your age, you have to enter a number. You cannot say your age is eggs or your age is potatoes. Your age has to be a particular number. If they ask for your name has to be a series of characters, what is known as a string. So whatever value that you enter in there belongs to a particular type, be it an integer, and so on and so forth. So you'd see that different data types usually can be grouped into two, either primitive or collections. Collections are more or less like sequentials, groups of stuff. right? You can have apples, a bunch of apples become a collection of apples, or you can have apples, bananas, oranges, then that becomes a collection of fruits. Or you can have oranges, eggs, plantains, bread, then it becomes a collection of food items, right? So collections are more complex data types, but the primitive, native, black and white data types, as you can see here, are integers. Integers could be more complex to be float. Float is a short way of saying floating point number. Floating point number meaning that decimal point can be in any location. It floats between numbers, whether it's 1 decimal place, 2 decimal places, and so on and so forth. So integer is a whole number. A float could be having more precision. Boolean is also another type which has to do with true or false, yes or no. It was discovered by I think it's a certain French mathematician whose name is Boole, and they gave the name Boolean. Also, you have string. String is the one that's used for characters. You can have one character, you can have a set of characters. Think of hanging your clothes on a drying line, that those clothes make up a string. So you can say this is A, B, C, and D. It makes up a string of characters, which is a text or a word. All right. So all of those, again, the reason we do that is because we want to be able to specify what type of data so that we can know what operations we can do on them, which we'll talk about later on. And in Python, just like we started using the print function, you can use the type function to tell you the type of data that you have. Okay, so let's go in and try real quick. In here, let's escape from that. If I go into my Jupyter notebook, let's open a new one and type 120. That's a value. It doesn't mean anything at this point in time because I have not assigned it anywhere. I can press enter. Python just returns me that particular value. I don't think you guys can see. Let me try to make that bigger. Drag this over. So that is a value. Now, if I want to find out the type of that value, I'll go in and use the type function. Remember, functions always have parentheses around them. Within those parentheses, I give it a parameter. So in there, I can type in 120. And if I execute it, I can execute, or I can press Shift Enter on my keyboard. It tells me this is an int. If I went ahead and typed in mango, Python tells me that's an error. Why is that? Because mango is not defined. It thinks it's something else. The way you write strings, you have to put them in quotes. So when you put strings in quotes, then your computer, your interpreter, Python understands that that is a string. You yourself, when you see it, you understand that is a string. So let me make this smaller a little bit. So this error is telling me there's an input error in item number 3. It does not know mango at all. So this is an example of us making a mistake in our language. This is an example of us talking gibberish, right? Which is totally okay. It's totally fine. You know, if it was a whole long script, it would be able to tell us where exactly on that script that the error is. In order for us to fix it, all we have to do is make sure that we type in mango in quotes. If I do that, then it knows that, okay, you're telling me that is a string. Does that make sense? Awesome, awesome. So again, these again are just literal values that you're writing in your Python console. Okay, the values don't really mean much now. We just know that each value has a particular type. All right, so let me switch back over and then we can go from there. Let's see something more interesting. I mean, if we're going to be writing code, there's a way that we probably want to be able to keep track of our values, okay? If we want to keep track of our values, we need to take them and store them somewhere, okay? So a value has to be given a name. We usually give names to values. Those are referred to as variables, okay? So think about, you know, I cannot be holding my mango in my hand and grabbing mangoes from left and right. It's better for me to put it in a bucket. And then I know that that bucket is DK's mangoes. If you want to pick up your own mangoes, pick your mangoes and put in your bucket. You put a tab or a tag on it, container, you know that's yours. So yesterday we talked about how we write programs and save them in memory. The reason we have these variables is because we are giving ourselves a location in memory to say, okay, save me this value in here. Tomorrow I'll come and look for it. Or another day I might come back and look for it. Just like, you know, you can be receiving your paycheck and eating all your money, or you can decide to open a bank account. When you go and open a bank account, you have to say what type of account it is. So think about this like going to create a bank account. Some people would want to be putting their gold in there. Some people might be putting their jewelry. Some people might be putting their books or important documents. That is why we need to define the data type. If the computer knows that you're going to be storing integer, it knows I'm going to keep you this space. If it knows that you're going to be storing a string, then it looks for a bigger space in memory that's going to be reserved for that. So each of these data types have different ranges in their sizes. That's why the computer can know that. But importantly, you want to give it a name, okay? So you write an assignment statement, which we'll talk about later on, to be able to create a new variable and give it a name and then assign that value in there. So I'm going to get a bucket, give that bucket a name, take my stuff and put it in there. Or I'm going to get a safety deposit box, give it a particular number. You have the key to that box, you know that's where all your stuff is, okay? Because throughout your lifetime, throughout the lifetime of your program, you're going to go back in there and grab that number and use it. But remember that just because you open your bank account with $100, it doesn't mean your bank account is only going to have $100. Tomorrow, you might decide to remove that $100. The next day, you might decide to add $3,000 and so on and so forth. So it's just a bucket. The values that's going to be assigned in there is going to change along the way as your program continues to execute. Make sense? So that's how you would define a variable, okay, just a placeholder. But as much as we know that, you know, we have the liberty of giving our variable any name, Python has a few recommendations. Variable names cannot be any of these words, these keywords, because these words, Python uses it for its own native programming. Words like false, none, true, del, def, continue, class, and so on. If you try to give those names to your variables, the Python interpreter is going to yell back at you and say no can do, okay? So what you need to do is you need to give it any other name. Most people will write programs and say A equal to this, B equal to that, C equal to that. That's not a very good idea. The names that you give for your programs need to be mnemonic. It needs to mean something to you. Because guess what? You're going to come back tomorrow to look at that code. You're not going to remember what the heck you were doing. Somebody else on your team might be looking at that code and be like, what did he mean by XYZ equal to this? So it's better to give it a name that has a good meaning. And that's going to be, I mean, nobody in the programming world wants to be looking at somebody's code with some names that don't mean really much stuff. So give some good names to your variables and it's going to save you a lot of headache, okay? Another thing is there are some illegal names that you cannot give. Just like I said, these keywords. We talked about languages. When you grow up, they tell you there are some bad words that you cannot say. If you say those bad words, you get a whooping. So think about it. It's the same thing in Python. No cannot use these bad words because you get a whooping. Also, you cannot start giving the name of a variable with a number. It must start with a letter, or you can start with an underscore. Most of the time, they don't want to use underscore, except you're using it for a library that you want to export. So you want people to use that specific name. But remember, again, there are some illegal names that you don't want to use. There are some names that are totally meaningless, except you make it mnemonic. Finally, in Python, there is encouragement of using a snake case. Is anybody familiar with either snake case, camelCase, or PascalCase? Not at all. Everybody is on mute. Go ahead, Aaron.
No, just hearing that for my first time.
Okay, so normally, let me go ahead and get out of here again. Normally, when you write words, right, you can write it in uppercase or lowercase. So let me go ahead and add a new cell. This would be uppercase, and this would be lowercase. But in programming, in most programming languages, rather than having the boy as the word, they'll usually take away the space in between the E and the B to join it together to be one word. Okay, so if you write it that way, that is, let's say, proper case. But if you want to write camelCase usually starts with a lowercase, and right after the space, you capitalize the next word. So that will be camelCase. That's why you see I write it this way, camelCase, because this C right here makes it look like the hump of a camel. Okay, but in some cases, you might need to start with a capital letter. If you start with a capital letter, then it is PascalCase, because Pascal is the name of a person. Pascal is, I think, is a French mathematician that I'm not sure what exactly he did. So that's the difference between proper case, camelCase, and PascalCase. Now, snake case is when you use an underscore. And Python uses snake case because it's more readable. It's easy for you to read that rather than the camelCase, because you have to squint to see if it's uppercase or lowercase. Does that make sense? So the names that you give your variables, you're very much encouraged to use snake case, but nobody forces you, but it's just programs that you see out there. Most of them will have snake case for Python. For other programming languages, it might be different, but this is what's encouraged for Python. Sounds good? Great.
Yeah.
Question, Mr. Nigel.
Yes, Prof. So, for example, I know. So you have written snake. Just to get it correctly, you have written snake case in snake case, right? So
yes,
if you were to write the boy, you will have all lower letters with an undercase in between the E and the C.
Yes.
And the okay.
That
All right,
that will be the boy in snake case.
All right,
Excellent.
gotcha. Thank you.
You are welcome. Question, Aaron.
Yeah, not that I know what I'm doing actually, but it looks like so. So so technically you cannot use proper case, right?
Technically, you can use anything, but if you share your code with someone that is wanting to use Pythonic code, remember Pythonic code when we talked about, let me open a new cell. When we talked about import this was giving you all the ideas of how you want your code to look like. Okay, so when you write the boy in snake case, it's actually talking about sparse is better than dense. Because of that space in there, you can clearly read, you can clearly see what is actually going on, and it's easily readable. But that's fine. If you want to make it dense, that's totally fine. It's just going to be not as readable as the sparse one. Does that help?
Yeah, because actually I've been using Pascal and Snake, just mixing them up without even knowing what I was doing, right?
Yeah.
Now,
Yeah, if somebody looks at your code, then they'll be like, yeah, your code is not very Pythonic. And you'll be like, what are you talking about? But it's not a big deal. Your code is going to run totally fine, no problem. But if you want to have your code to look clean and neat, then you want to, everybody is encouraged to use Snake Case.
okay, that's good to know. Thank you.
You're welcome. You're welcome. And a question from Fabian: are the words case sensitive? They are case sensitive. So I think to really answer your question, we'll probably have to go to the next slide and then test it out so that you can see clearly what exactly is going on. But Python is definitely case sensitive. If you give...
This was long before it was, I was asking about the keywords, the ones that you said are reserved words.
Oh, yes, the keywords.
Because I saw like from with uppercase, F, but I don't know whether if we were to use from with lowercase, it would still constitute a reserved word.
Good. So the best thing we can do right now is let's figure out and answer your question. So let's try to create a variable, right? An example of a variable we had, what number did we use before? We said 120. So let me go ahead and say the, I don't know, number of mangoes. Number of mangoes is equal to 120. That's how I'll go ahead to create a variable called number of mangoes and assign the value. This is an assignment operator, and I assign the value of 120. And if I press enter, nothing really gets done because I'm not printing anything to the output. If I use that print function that we've been using all along, and now I type in number of mangoes, what I did here is I started typing NUM, and then I used the tab to complete it for me. Okay, because that's the only one I have. So if I press tab, it completes it for me. It helps me avoid having typos because I might make a mistake. So if I print that and I do play, it prints the value that is inside that bucket, that is in that memory location, because there's a memory location in there. I could go ahead and just say A equal to 120. And then I can go ahead and print that A. It's still going to give me the same answer. But when you come back tomorrow, you're going to ask yourself, what was A? Was it bananas or oranges? That's why it's better to give your variable a mnemonic name, a name that actually means something, rather than having that. Obviously, you're not going to go ahead and say 6 mangoes equal to 6. That's going to give you an error if we try executing it, and that's because it's an invalid syntax. You cannot start the name of a variable with a number, so that's illegal. Okay, so if we try using the from to be a variable, you can see that it's already highlighted because this is an IDE. So if I say from equal to 7 and I execute that, it's also going to give me an error because from is a reserved word. If I use a capital letter equal to 7, then it's not an error. So it's not or it is case sensitive rather. Does that make sense?
Perfect. Thanks.
So now I can go ahead and print from, and it should be just fine. But obviously you want to avoid using any of those keywords because it's going to be problematic for someone to try to read your code. Sounds good? So definitely you don't want to give your variable a name like this because this is going to be causing you a lot of you're going to become very unpopular on your team when people start seeing you writing code like that. So it's better to go ahead and just say mangoes or maybe singular, and you're fine. When you execute that, this has been saved in Mango. No matter when you come back and you execute it, it's going to be able to know that that's the value that you saved in that memory location. And the CPU can take it from there and run with it really, really quickly. Everybody good with this so far?
Yep.
Excellent, excellent. So the reason, again, as you can see, why I'm using Python with Anaconda notebook, or should I say Jupyter notebook, is because we can test these things out easily. We can write every single line of code and execute it easily, rather than using a Python script. Eventually, we're going to start using scripts when we have gotten to the meat of it. But for now, understanding the basic concepts, we need to be able to just break it down in here. Like I said, don't be afraid that you're going to break anything. Just go ahead and test out your scenario and then figure out what the issue is. Sounds good? So a quick example we might want to do, let's say we want to solve a particular issue of calculating tax. And I think I'm probably going to show you that in a little bit. Let me make sure that I cover something else that we might need, which is a statement. And before I cover a statement, let me go back and make sure that we double check again. We've gotten everything on here, all these keywords. False always starts with a capital F, true with a capital T. The rest of them are all lower cases. So definitely case sensitive. Or actually none, I've totally forgot about that. None is also capital N. Okay, so we've talked about values, we've talked about data types, we've talked about variables. Let's proceed now and talk about statements. Okay, a statement is an instruction, just a line of code, right? That's pretty much a unit of code, but the statements could be executed or not executed. The statements that are executed are usually not commented out. So sometimes you want to skip a line of code if you have already gotten what you need, or for debugging purposes. You might also want to write information in your code that's going to be helpful for you in future or for some other person looking at your code. In that case, you add a pound or a hash or a hashtag in front of the code, and it's going to be skipped when the interpreter goes over it. Okay, so that's what a comment is. Every programming language has a comment. That's usually, in the past, it was mostly used for, adding information about the code, but now in production code that lives in a production environment or in a live environment, it's really frowned upon. But it's good to have it in your development environment to help you out, to say, if for instance you want to solve a problem, you might outline the steps to solve the problem and then go after each comment and write the actual code that needs to be done. That's known as pseudocode. Writing code in your own words and then going in to use the programming language to actually write the particular thing that you're trying to solve, the problem you're trying to solve. So again, a statement, as you have seen, multiple statements that we've talked about today. Your statements, if you write them in the interactive mode, just like we've been doing in each of those cells, just like you can do on the console in Python, using the Python, should I say the Python IDLE, the Integrated Development and Learning Environment. What happens is the interpreter reads it, it executes it, it displays the result if there's one, and then just loops back. That's what REPL stands for. Read, evaluate, print, and loop. Okay, so that's how you execute each line of code. But if you decide to write multiple statements or even one statement in a file and save it, that's still a Python script. So if you write print hello world or print your name, that is a Python script that has one instruction that's saved in a file. Make sure that your file ends with .py for Python. If that's the case, whatever happens when you execute that file, which contains a sequence of statements, the results are also going to appear on the console, one at a time, one after another. If you write a piece of code, let's go back in here. Let me, oops, not there. All right. Let me switch back to the other screen. If you write a piece of code that says, in this case, we have mango, from, and so on. If I go ahead and do print from, and then I do print mango, oops. And then I do print, let's say hello. Oops, that was a typo right there. This will be more or less like a script. If I execute this, it's going to go ahead and print all three of them. It remembers that from had 7 assigned to it. It remembers that mango had 21 assigned to it. And it also goes ahead and prints this. Does that make sense to everyone? And just like we said earlier, if we want to check what data type is in the mango, maybe we did not know, all we have to do is do type, and then we enter mango in there, because mango is a variable. Mango is holding the value that we have assigned in that space, in that container, in that memory location. If we execute this, it tells you mango is an integer. Question, Fabian?
Yes, I have 2 questions here.
Yes.
One, you said REPL is read, evaluate, or what were the other 2 ones?
So it's read,
yes,
evaluate, print, and then loop. So
okay.
after it prints, it looks back and then it asks for more, because that guy is just hungry. That CPU is so fast, all it wants is that you should give it something to do. So it's whatever you give it, it's going to read it, evaluate it, give you the result, and then ask you for more input.
Okay, given the example that you just did,
yes,
if you scroll, okay, we know that we had defined the variable or assigned a value to the variable form, then
yes,
mango in that order,
yes,
right? But if we were to reverse and put print mango first, then from down, would it, that sequence, what is the sequence there? How does it read, like from top to bottom based on how you define it? I know with other programming tools, for example, say like Terraform, when you're defining AWS resources, Terraform is actually intelligent to know that, okay, I need to create this before this. You don't necessarily need to place them in a specific order, right? But in this case of Python, is it the same concept?
Yes. Again, what you did here is, this guy comes into the bank and he says, I want you to take 7 and save it in this space. Another guy comes into the bank called Mango. I want you to save 21 in Mango. They are all located in memory. Memory can pick it up in any order. But when you come now and ask a question with the print function, you're saying, hey, print mango first. Sorry, print from first, then print mango, and then print hello. Then it's going to do it in that order. That's why in here, I did mention that, oops, wrong one. The results would appear one at a time as the statements execute.
Okay.
Okay, so the first statement to execute, oops, I keep doing that. The first statement to execute is the print from. The next statement to execute is the print mango. And the last statement to execute is the one with the hello.
Thank you.
You are very welcome. All right, very good questions. Any other questions, anybody? Yes, Mr. Anji.
So, Prof, because I'm just a follow-up on that question that you just responded. Consider we write a print statement saying, okay, print mango first, and then print from second, and then finally print hello everyone. Is that still gonna come?
as you give the statements, or does it have to follow just that format and say, okay, Mango first came in first, let me give him the result. Then sorry, from came first, let me give him the result. Mango came second. I don't know if that is clear.
Very good question. So again, let's try it out. If I go ahead and say print 1 + 1, and then I go ahead and say print Mango, and maybe go ahead and say print how are you, it is going to first print 2, and then print whatever value was stored in Mango, and then print how are you. And let's go ahead and even print from as well. And you'll go ahead and print that as well. So let's execute that. And you see it prints it in that order. Does that make sense?
Yeah, clears my doubt. Thank you.
Excellent. So pretty much, again, it's the order in which those instructions are given. So that's why it's very important to list your instructions in order. Just like we said yesterday, if you have given instructions to your child that every time I tell you get ready for school, you have to first go and make breakfast before you brush your teeth, before you make up your bed, and so on. That's the order that it's going to follow. So if the order does not work, you have to go back. That's why in software development, there's the planning phase. You go ahead and plan and get all the information that you need. They'll do the designing. They'll say, okay, the system has to do this and that before it does this and that. And then you go into development. After this is been designed, you develop it. And then those other guys that are quality assurance guys, they do quality analysis, or quality engineers to come in and test it to make sure that what you want is what you're actually expecting back. Okay. So again, you want to make sure that there are two types of errors actually. There's a semantic error and there's a syntactic error. So semantic meaning it sounds correct, but it's giving you the wrong thing. While syntactic, it means you're not writing it correctly. So for instance, I know that I want to say the cost of something is equal to 1,000. Okay, that's good. I can now go ahead and say print the cost. If I do this, I don't get any errors. But if I went ahead and said the new cost, new cost is equal to 1,000. That is a syntax. That is a syntax error. Okay. Because now, sorry, I actually made a mistake. I needed to print it. So let's print new cost in this case. If I print new cost, that is not what I was expecting. Okay. Because I entered it with a comma, Python is thinking that I'm entering two separate numbers instead of entering one number. So even though we know 1,000 has 3 zeros, you don't need to add a comma in there. So here it did not tell us this is an error. If I had another, let's say another cost, say it's equal to 1,000, and then I print another cost. This works just fine. So this is a good answer, and that is a wrong answer for this one, because if I went ahead and got this and I don't print it to see what my value is, tomorrow when I want to use that value, I'll get an error message, not knowing that that's because I had a comma in there. Okay. Again, if I add another value and say, let me put A in there and try to print it, it gives me an error. This is a syntax error. This is a semantic error because it doesn't do what we are expecting it to do. Does that make sense to everyone?
Yes, so line 20, to solve that, would you wrap it in double quote or?
Very good point. So to solve line 20, the question that Fabian is asking, should we wrap this in double quotes? That would definitely change the issue. It's not going to solve it though. So rather than me doing that, let me undo that and then let's try it in another cell. Let's say newer cost is now equals to, even if we do 100, 1000, and go ahead and print newer cost. What do you guys think we'll get? Anybody?
Yeah, it's gonna be a string, right? It looks like it's gonna be a string.
There you go. Very good, Aaron. So it prints that out, but what we need to do is check the type. If we type it out that way, we can see that newer cost, is going to tell us that is a different data type, str for string. Does that answer your question, Fabian?
Interesting, yeah.
Yes, so you have to be very careful. Like I said, the CPU is very dumb, but very fast. So whatever you give it, it's not going to figure you out and say, you know, this is what you're trying to do. That's why if we go back to our Zen of Python, it's better to be explicit than to be implicit. You know, as much as we're implying that we want it to be 1000, we should definitely be explicit. And your friend is always going to be this type function to check out what exactly your data type is. So those are ways that you can debug. And that's something we talked about yesterday, that Python was dynamically semantic or something like that. You know, it was not static. It did not have static semantics. In other programming languages like Java, C, and so on, before you want to use newer cost, you have to define it. You have to say, hey, I want this variable to be of this data type. But in Python, you don't define any variable. You just go ahead and create it, and then you're good to go. So for some people, it's a good idea. Others, it's not a good idea. Most people that do testing, quality engineers and quality analysts, they would not like it because they'll have to go in and test. You know, this is probably one of the things they'll do to test and make sure that your data type works just fine. Sounds good? What questions do we have?
No, but you had an alternative to fixing that line 20.
Yes, an alternative to fixing line 20 would be just to take away that. Why is it not? Take away that comma, and then it's pretty much just like line 18 now.
Oh, okay.
So if I execute this, now it's 1000. Okay.
Okay.
Another thing we might do, which is data types, as you see, newer cost is now a string. We can go ahead and convert it. For instance, we can say newer cost with a comma or without a comma. This is still going to be a string. Okay. But if you want to convert one data type to another, I don't actually have it in my slide because I was hoping to tell you guys later. I can go ahead and change my newer cost to be an integer by casting it. So I would say int and do that. So it's saying take this number, whatever it is, change it to an integer. So I can go ahead and say this is integer cost. And this value now gets assigned to integer cost. And I can go ahead and print that. I can also go ahead and check the type. So again, 3 things are going to happen here. The first line is going to go ahead, take newer cost, convert it to integer, and assign it to integer cost. The next line is going to print that value within that container, within that bucket. The third one is going to give us what type is in there. So let's go ahead and execute that. You can see 1000 is now an integer.
Oh God, you're making this whole thing really fun.
That's good. That's good. That's good. That's the point, that's the point of us, doing it this way. So going back to our PowerPoint, we have seen a few things here. We've seen that a statement, you can write it interactively on the console and it will read, evaluate, print, and loop back and ask you for more stuff because it's that hungry. You can write it in a file, save it, and then execute that file. The results are going to appear one at a time. But there are two types of statements, as we have just seen. There are statements that are used for assignment. So you're taking things and assigning them to variables. In that case, you have no output, right? And that's something we just saw right here. I wrote 3 statements. This first statement did not have an output because I just assigned it. Only these 2 statements had outputs. The first one that printed and the next one that gave us the report that it's an integer. So 2 types of statements. Assignment statements has no output. Expression statements has an output. But the expressions is the next thing that we're going to talk about. But I think we are about 1 hour into our lecture, so it's time for us to take a break. We had to talk about expressions and then take a break, but we're going to take a break now. When we come back, we're going to jump on expressions. Does that sound good to everyone?
Yeah.
Awesome. We don't have much else to go. We just have to take a break now, 10 minutes. When we come back after 10 minutes, we'll look at expressions. We'll start having users to input stuff, and then it gets even more fun. Sounds like a plan?
Yeah.
Awesome, awesome. So please come back from the break with a few questions. Let me go ahead and put a 10-minute timer, and we will be back. In the meantime, I'll see if I can find some music too.